Good morning. My name is Harish Bandari, and today I'll be discussing the solution to the single greatest hurdle facing the next generation integrated photonics, that is, fabrication induced phase errors. We are at a tipping point where photonic integrated circuits are poised to revolutionize everything from quantum computing, artificial intelligence, to guidance systems for long range missiles. But until now, we've been fighting a losing battle against material variations and fabrication tolerances. At radiation monitoring devices, we've developed a way to fix that directly on the chip and at the atomic level. RMD isn't just a research house. We are a deep tech engine founded in 1974 with a mission to move world-class science into exceptional commercial products. With over 80 patents and a specialized focus on advanced thin film technologies, specifically atomic layer deposition or ALD, we have the infrastructure to solve complex material challenges. Our business model is built for partnership. We license our proprietary processes and provide a critical components to defense primes and commercial giants alike. Here, we discuss specific needs related to inertial navigation systems using photonics. We want to swap size, weight, and power benefits of integrated photonics for unmanned aerial vehicles, missiles, and satellites, especially in GPS-denied environments. But here's the reality. Even the best foundries produce chips with performance-degrading phase errors. The problem? Fabrication variations create phase shifts that ruin the photonic chip reliability. This can be catastrophic for aerial navigation and guidance systems. What is the current fix? We use power-hungry thermal heaters to tune these errors back into place. The Navy's specific needs are sub 1 decibel loss and precise 2 pi phase shift within a tiny 5 micron footprint for on-chip phase trimmers. Current methods are too bulky, can run too hot, and are too power intensive for a missile or a drone application. The Navy's Strategic Systems Program, SSP, need assured precise navigation for assets like Trident 2D5 missile. When GPS is jammed or unavailable, we rely on inertial sensing. By transitioning from bulky fiber coils to integrated photonics, we can dramatically reduce the footprint of these guidance systems. But to make that jump, we need a way to trim the circuit after it's built. Our ALD technology provides a non-volatile solution, meaning once we fix the error, it stays fixed, even when the power is off. This is the set and forget calibration the fleet has been waiting for. Here is the breakthrough. We are integrating phase change materials onto photonic circuits using atomic layer deposition. Why ALD? Most PCMs, phase change materials, are sputtered, which is fine for simple films, but a nightmare for complex 3D photonic topographies on large wafers, commercial scale wafers. Our ALD process allows us to grow these materials with atomic precision directly onto silicon and silicon nitride waveguides and is easily scalable to a foundry level compatibility. Dynamic and non-volatile. In the sense, we can switch the phase change material between amorphous and crystalline states to trim the phase, enabling complexity. This isn't just a patch, it's an enabler. It allows us to build larger, more complex photonic fabrics that were previously impossible to manufacture because the cumulative phase errors would have driven the yield to zero. We aren't just talking about theory. In phase 1, we successfully demonstrated ALD growth of phase change materials and reversible phase switching reaching TRL3. We are currently in phase 2, fabricating test structures with photonics to validate this integration in a commercial grade environment. By the end of this effort, we plan to deliver 5 prototypes to the Navy, having reached a TRL level 5. So let's compare our phase-trimmed waveguide optical gyroscopes shown here with the traditional fiber optic gyroscopes. Power. Traditional active phase control is a constant battery drain. Our solution has a zero power hold. You set the phase and it stays there indefinitely without drawing a single watt. Scalability. Traditional gyroscopes are labor-intensive assemblies. Our process is foundry compatible and scalable through standard CMOS-like ALD process. Performance. We offer assured navigation in environments where GPS simply isn't an option. Our path to the fleet is direct. We are leveraging the AIM Photonics test chip platform to prove that our ALD process can live inside a high-volume foundry. We aren't just building a laboratory curiosity. We are building a manufacturing standard. Beyond the Navy, we are aggressively pursuing dual-use opportunities that will lower the cost and increase the availability of this technology across the DoD. Now, for the technical managers in the room, think beyond navigation. This is about photonic era computation. AI, artificial intelligence, and matrix multiplication. In neuromorphic computing, the weight of a neuron can be stored in the state of a PCM, phase change material. Our ALD process allows for the high-density integration needed for optical neural networks. Optical communication. In data centers, we can use this for non-volatile switching and routing, slashing the energy bill of the world's most power-hungry infrastructure. LiDARs. For autonomous systems, we provide the phase stability required for long-range, high-resolution sensing. Whether it's quantum photonics or biomedical imaging, if you need a scalable way to control light on a chip, you need ALD integrated PCMs. To make this the global standard, we need you. To the primes in the audience, we provide the solution to your manufacturing bottlenecks. Let us help you deliver high yield photonic integrated circuit systems. To the foundries in the audience, our process is designed to be plug and play within the DoD trusted foundry environments. We are seeking strategic partners to transition this technology into the next generation of military and commercial systems. We solve the errors, you build the future. Thank you for your time. Again, I am Harish Bhandari, and I look forward to discussing how our non-volatile phase trimming can unlock the potential of your photonic systems. My contact's on this page. I say, let's build the next generation of integrated photonics together. Thank you again.